Hello everyone, it's another problem. So we have a roller coaster problem. So that it says that the essentially it's at rest. So at point A, it was at rest, and then it comes to point B with a speed of 100 kph. Okay, and then find the required height. That's the question. Find the required height. And then says that what is the minimum radius of curvature rho, so that the at point B the passengers do not experience a normal force greater than 4 mg. Okay, that is the question. So 4 times their weight. So at point B, what is the rho, so that the passengers do not feel a normal force that is greater than 4 times m into g. Now let's try to solve it. First, I will start with the required height h, and then we will move on to the next part. So again, our famous equation, guys, that is the work from 1 to 2 is kinetic energy at 2 minus kinetic energy at 1. And then kinetic energy at 1 is 0, because it starts at rest. That's kinetic energy at A. And then kinetic energy at 2 will be equal to mv2 squared by 2. And then we have 100 kph. And then 100 kph. So it will be times, let me put it this way, 100 kilometers per hour times 1 hour is 3600 seconds, and then 1 kilometer is 1000 meters. From here, if you do the calculation, you will get, let's go to Excel. So we have the 100 by 3600 and times 1000. Get 27.8 meters per second. So that will be, the m is not given, 27.8 squared by 2. Okay. That is the kinetic energy at point 2. So let's take the square root of it and then divide by 2, and that makes 38.80 m. Okay. And then there comes the net work, or the works acting from 1 to 2. So we have 1 weight, and then do we have another force? No, we have only weight. And then weight is, if I go here and add this is our roller coaster. Let's extend it to here. So this is the, let's take any point here, and then weight acts this way, and this is the direction of the weight. Any point, the weight acts that way. So if I take my coordinate here, let's say that this is the coordinate y. Okay, and then at point here, so if you just notice that the weight and the motion are in the same direction. Okay. Therefore positive. So I will just put that m into the g and into the difference here, which is the h. Okay, that will be the work by weight. So Now the time is to equate the left hand side with the right hand side. That will be mgh will be equal to 35.80 m. Okay, then this cancels out, then h will be equal to that one divided by 9.81, 39.3 meters. Okay, so we solved the first part. The second part says that what is the radius of curvature at point B so that the passengers do not experience a normal force greater than 4 mg. Let's do that. So this is our point B. So this is point B. At this point B, we have a normal direction. Okay, and then we have a force in that direction. So this is, let's say, let me put it the other way around. So we have a radius of curvature rho, then we have a normal direction which is n, we have the force which is f of n. Okay, that's the force, and then we have the weight of the people, and then Newton's second law says that the forces acting in the n direction will be equal to the mass into the acceleration in the n direction. Okay, let's write in scalar form. So we have a weight that's negative. We have Fn, which is positive. That is equal to the ma into the n, which is positive. So that will be, but we know that the an is v squared by rho. So let me just add it. Weight is a negative m into g plus, and then Fn, the question says that Fn is 4 mg. That's given in the question. Let's see. And that will be equal to the m and then v squared by rho. And then cancel all the m's. M cancel. And then the v square is, we can find it. Then rho will be v squared by 3 into g. Okay, that we can find very easily. Let's do that. So velocity is this one. So it will be that will be equal to velocity squared by 3 times 9.81. That is 26.2 meters. That's the end of the problem.